Question number 29 is requested. We have a car that is at rest. So since the car is at rest, that means that the forces on it are balanced. We have force of gravity straight down. So force of gravity will be manifesting itself in two directions, in the perpendicular direction and the parallel direction to the incline. So this is mgx and this is mgy. Because the force of gravity is balanced by normal force, I'm going to draw one. Now careful, it has to be perpendicular to the surface and equal to gy. So this is normal force equals mg cosine of 15 right there. Force of friction. Now here's the funny part. How big is the friction force on the truck? The coefficient of static friction between the tires and the road is 0.9. They are tricky because what they're giving you is the belief that you could use force of friction formula static, that equals mu static times mg cosine of theta, 15 degrees in this case. It will be 0.9 times 4,000 times 9.8 times cosine of 15. Grab your calculator and see what the answer is. I'll do the same. I got 3.4 10 to the 4th. If the truck is at rest, you know that force of friction static, or force of static friction, should be equal to the mgx, which is the component of gravity that is trying to drag it down the incline. And that would be 4,000 times 9.8 times sine of 15. And that, if we round it to appropriate number of sig figs, which is technically 1, it's only 10,000. So see how we went from 34,000. That is the correct answer. Coefficient of static friction allows you to find the maximum static friction. So this is the number that represents the maximum available static friction. But because it's only at 15 degrees slope, your force of friction static, it equals just the amount of the gravity drag down the incline. Force of static friction, remember, is a very, very lazy force. It only gives you the amount of effort that is required, no less, no more, until you break or exceed its maximum value.